बादाम अब सिर्फ 269 रुपए किलो, काजू मात्र 299 रुपए किलो। और यही नहीं, खास कॉम्बो ऑफर पूरे 4 किलो सिर्फ 9।
आज गली गली अवध सजाएंगे, आज पग पग पलक बिछाएंगे। ओ आज गली गली अवध सजाएंगे, आज पग पग पलक बिछाएंगे। आज सूखे हुए पेड़ फल जाएंगे, नैना भीगे भीगे जाए कैसे खुशी छुपाए राम आएंगे। कुछ समझ न पाए कहाँ फूल बिछाए राम आएंगे। नैना भीगे भीगे जाए कैसे खुशी छुपाए राम आएंगे। कुछ समझ न पाए कहाँ फूल बिछाए राम आएंगे। आज सरजू के तट मुस्काएंगे, मोर नाचेंगे पपी है आज गाएंगे। आज दसो ये दिशाएं जैसे शगुन मनाए राम आएंगे। नैना भीगे भीगे जाए कैसे खुशी छुपाए राम आएंगे। कभी ढोल बजाए कभी द्वार सजाए राम आएंगे। कुछ समझ न पाए कहाँ दीप जलाए राम आएंगे। जाके आसमानों से तारे मांग लाएंगे, कौशल्या के लल्ला जी तुम्हीं पे सब लुटाएंगे। 14 साल जो रोके वो आंसू अब बहाएंगे। अवध में राम आएंगे, हमारे राम आएंगे। नील गगन से सांवले कोटि सूर्य साथे, नारायण तज आए हैं शेषनाग की से। राघव राघव करते थे युग युग से दिन रहे, आज प्रभु ने दर्श दिया धन्य हो गए हैं मैं। नतमस्तक है 3 लोक और सुर नर करें प्रणाम। एक चंद्रमा एक सूर्य एक जगत में राम, एक जगत में राम। आज दसो ये दिशाएं जैसे शगुन मनाए राम आएंगे। नैना भीगे भीगे जाए कैसे खुशी छुपाए राम आएंगे। कभी ढोल बजाए कभी द्वार सजाए राम आएंगे। कुछ समझ न पाए कहाँ दीप जलाए राम आएंगे।
गुड मॉर्निंग सर। हेलो।
हेलो।
यस सर, गुड मॉर्निंग सर।
है गुड मॉर्निंग सर।
सर एक बार ना आप पीपीटी अपना शेयर करिएगा, अपना कैमरा ऑन करिएगा सर।
हाँ सर, कैमरा मेरा, हाँ, एक मिनट जस्ट। आई थिंक सर स्क्रीन विजिबल है क्या?
नहीं सर, विजिबल तो नहीं है सर अभी।
हेलो वासने साहब।
शेयर कर दिया है।
बट सर स्क्रीन आपका दिख नहीं रहा है सर यहाँ पे। यस
सर
सर,
यहाँ
दिख
से
रहा है,
मैं
विजिबल है,
शेयर कर दिया, अब शेयर।
विजिबल था सर। यस सर, विजिबल है।
ओके ओके।
विजिबल है, सब
अभी
कुछ
स्लाइड्स मूव
शेयर
कर
है।
रही है सर।
यस
ओके
सर।
सर। ओके सर ओके।
सर हमारे साथ ये एक्स डायरेक्टर हैं एलएम के बीएन डिस्ट्रिक्ट सर।
नमस्कार सर।
नमस्कार वासने साहब जय, कैसे हैं?
मैं सर ठीक हूँ सर, आप कैसे हैं?
हाँ बढ़िया है जो है। तो दिल्ली में ठंड थोड़ी बढ़ गई होगी।
हाँ सर, थोड़ा सा टेम्परेचर बढ़ गया है, तो कम हो गया, मतलब ठंड बढ़ गई है।
हाँ वही वही, ठंड बढ़ना मतलब टेम्परेचर कम होना।
कम होना, हाँ।
लेकिन लोग बोलते हैं कि ठंड बढ़ गई।
हाँ हाँ सर।
सबकी भाषाओं की टर्मिनोलॉजी है जय।
हाँ सर।
तो सर जो है आज जो है आप फ्लो मीटर पर बोलेंगे जो है।
हाँ सर।
सो लेडीज एंड जेंटलमैन, all the legal metrology officers who are participating in this very program, scientists, industry officers who are the part of this very programs. Today I welcome Mr. Anshul Vatsne. He is the senior scientist from CSIR National Physical Laboratory,
यस सर।
So he is having the very good knowledge on these very subjects. The flow meter is also the part of the legal metrology.
यस सर।
The water meter also, the flow meters also, the various type of flow meters has been prescribed in their specification meter for liquids other than waters. So all those things has been given there. The people might be knowing there, all the enforcement officers who are verifying all these very things. So they are well aware there how to verify all these very things there. Lot of industries are there in various part of in the various part of our country in various states. So particularly in Maharashtra and Gujarat, there are a lot of industries are there. So people are might be getting benefit from those very things. So in weights and measure, if nothing is verified, it cannot be used. So before verification, all the inspector used to go to its premises where the uh, all the standards are there and the under test are there, and on that very bench of the flow meter, these things are being tested. And after testing, it is verified, then it goes to the market for selling and verification, selling and installation, both purpose. So it is not only with the flow meters, you see that there is the uh, dispensing pumps also. Dispensing pumps, which is meant for the flow meters, meant for the petrol measurement,
Yes.
diesel measurement, and CNG measurement, that also is part of the flow meters. So earlier it was the different from the flow meter for liquids other than water. Now everything has been contained. There are the various flow meters which is used for the LPG measurement, CNG measurement, and so many other type of things also, sir. Even for the PNG measurements also, sir. So all things has been defined under the flow meters, sir. Today we have got the very good opportunity that one of the big scientists is before us, sir. So I hope that Anshul Varsne will enlighten all the things that how to measure all these very things and how to test it, how to calibrate it, what the precaution has to be made, and so many other this type of things. So from this very forum, I welcome Dr. Anshul Varsne Saab, sir, and I will request him to start his lecture, sir. Thank you, sir.
Thank you,
Sir.
sir.
Please start your lecture, sir.
Thank you, sir. Thank you very much. I am just closing my camera. Thank you, Dikshit sir, for throwing some light about the importance of fluid flow measurement. So today in this presentation, I will speak about progress and innovation in fluid flow metrology at CSIR NPL. What we are doing at CSIR NPL, what calibration we are providing in terms of water and gas. So I will give some brief introduction about these facilities which has been established as CSIR NPL. So before going into the detail, I will would like to go through some basics of flow. See what are the basics of flow measurement? What is the fluid? What types of flow meters are being used in industries, and which standard is being used for calibration of these type of flow meters? So I will give some little bit introduction about these uh, terms. So, what is a fluid? Basically, for what we are calling fluid. The definition of fluid is a substance in the liquid or gas phase which can flow, that is called fluid. And fluid doesn't mean ki we are talking about only water. Generally, in normal general terms, people consider water it is a fluid, but any substance which is in a liquid or gas phase that can flow, that is called as fluid. A solid can resist and applied shear stress by, you can see uh, by this figure. Uh, a fluid deforms continuously under the influence of a shear stress, no matter how small. However, in solids, this stress is directly proportional to the strain, but in fluids, stress is proportional to the strain rate. So when we are applying a constant shear force, a solid eventually stops deforming us at some fixed strain angle. However, in case of fluid, that never stops deforming or approaches a constant rate of strain. It continuously going on deforming as we are applying a strain. So you can see a deformation of a rubber block which is placed between two parallel plates under the influence of a shear force. The shear stress is shown that on the rubber an equal but opposite shear stress acts on the upper plate. You can see from this figure, when we are applying the shear stress, it continuously starts deforming in this direction, in the direction of force at a particular angle of that is called shear strain. So what is stress? Stress is generally known as force per unit area, and normal stress, this is the normal component of a force acting on a surface per unit area. And shear stress. Shear stress is basically the tangential component of a force acting on a surface per unit area. This one. And pressure, the normal stress in a fluid at rest. And what is zero shear stress? A fluid at rest is at a state of zero shear stress. When the walls are removed or a liquid container is tilted, a shear develops as the liquid moves to re-establish a horizontal free surface. That is called zero shear stress. In a liquid group of, you can see this in this container we have filled some liquid, and this container there is some gas. So in a liquid, groups of molecules can move relatively to each other, but the volume remains relatively constant because of the strong cohesive force between the molecules. Because of this, a liquid takes the shape of the container it is in. In whatever type of container we are filling the liquid, it forms a free surface, and in a large container it is in a because of gravitational field. However, in case of gas, it expands until it encounters the wall of the container and fills the entire available space. This is because the gas molecules are widely spaced and the cohesive force between them are very small. Unlike liquid, a gas in an open container cannot form a free surface. It will continue expanding until it will not encounter with any boundary or any wall of the container in which the gas is being filled. So now coming direct the application of fluid flow measurement. What are the application of fluid flow measurement? Like process control, nuclear power, aircraft industries, human life, power generation, fertilizer industries, beverage industries, distilleries, liquid industry, irrigation sector, pharmaceutical industries, gas industries, R&D laboratories, pollution controls, petrochemical, agriculture, and dairy paints, and different type of many other industries. Basically, at NPL, we are catering these all types of application to different sectors. So, if we are going in detail, like industrial application, what are the role of fluid flow measurement, monitoring and controlling fluid flow pipelines like oil, gas, water, and chemicals, optimizing fuel consumption in power plants, process control in pharmaceutical and chemical industries. Similarly, in environmental monitoring, fluid flow is used for measuring river and stream flow for flood prediction, monitoring wastewater discharge and pollution control, accessing air and gas emission in industries. For medical and healthcare, like in blood flow measurement in cardiovascular diagnostic, drug delivery system, basically syringe pumps, infusion device, analyzers, IV drips, inhalers, these types of devices where fluid flow metrology plays an important role. And respiratory flow monitoring in ventilators, like oxygen concentration, oxygen flow rate, inhale volume, exhale volume. These are the parameters as taken care by fluid flow metrology. In automotive and aerospace, fuel flow measurement in internal combustion engines, aerodynamic testing in wind tunnels, hydraulic system monitoring in aircrafts. Similarly, in agriculture and air irrigation, flow control in irrigation systems, groundwater and soil monitoring, fertilizer and pesticide distribution systems. And in HVAC and building system, it is in airflow measurement in ventilation and air conditioning systems, water flow monitoring in plumbing and heating systems, and energy efficiency optimization in buildings. These are the some sectors where fluid flow measurement is used. And these are the some application area of fluid mechanics. Like fluid dynamics is usually extensively in the design of artificial heart. You might have listened about the artificial hearts. So in artificial hearts, fluid dynamics is the major parameter which is used extensively in designing of these type of equipments. This is a basically artificial heart which is developed in Penn State. And another important application of fluid, natural flow and weather and power plants. Similarly, in transportation, in water transportation, aircraft and spacecrafts, human body and cars, wind turbines, piping and plumbing system, industrial applications. These are the some important applications where fluid flow measurement is widely used. In our, we can see these applications in our daily life. There are different types of flow which exist, like steady flow. So the flow in which the velocity of fluid is constant and at any point is called steady flow. So this is the example of steady flow. We are measuring the flow in present, and with the help of this present velocity, we can predict the flow velocity at some future points. However, in unsteady flow, the fluid velocity differs between any 2 points. At a particular point, the fluid velocity will be something differ, and at another point, there will be some another flow velocity. Similarly, uniform flow. In uniform flow, where flow velocity is the same magnitude and direction at every point in the fluid. However, in non-uniform, if at a given instant the velocity is not the same at every point, the flow in this type of flow, study on study I have explained earlier. Similarly, study uniform flow. In a study uniform flow where it do not change with position in the stream or with time. The example of the steady uniform flow, the flow of water in a pipe of constant diameter and constant velocity. That is an example of steady uniform flow. Similarly, a steady non-uniform flow, in which the velocity change from point to point in the stream but do not change with time. The example of steady non-uniform flow is flow in a tapering pipe with constant velocity at the inlet. Velocity will change as you move along the length of the pipe towards the exit. Basically, uh, it follows the continuity principle. So now, unsteady uniform flow, at a given instant in the time, the condition at every point are the same but will change with time. The example of unsteady uniform flow is a pipe of constant diameter connected to a pump, pumping at a constant rate, which is then switched off. Unsteady non-uniform flow, every condition of the flow which may change from point to point and with time at every point. The very basic example of unsteady non-uniform flow is waves in a channel. Now, coming to another type of flow, that is laminar. In laminar flow, all the particle proceed along a smooth parallel path, just as shown in this figure, and all particles on any path will follow it without deviation. Hence, all particles have a velocity only in the direction of flow. This type of flow is called laminar flow. Similarly, turbulent flow, the particle moves in irregular manner through the flow field. Each particle has superimposed on its mean velocity, fluctuating velocity components, both transverse to and in the direction of the net flow. So this type of flow is known as turbulent flow. And transition flow exists between laminar and turbulent flow. In this region, the flow is very unpredictable and often changeable back and forth between laminar and turbulent states. So that is called as transition flow. These are the some other pictorial example of laminar flow and turbulent flow. How you can understand about the nature of flow. Next, another type of flow is coming, compressible or incompressible flow. All fluids are compressible. Even water, their density will change as pressure change under steady state conditions and provided that the change in pressure are small. It is usually possible to simplify analysis of the flow by assuming it is incompressible and it has a constant density. The compressible flow, when the density of flow varies with pressure, it is termed as compressible flow. However, incompressible, when the density of flow does not vary with pressure, it is termed as incompressible flow. Next, another viscous or non-viscous fluid flow. Viscous flow, such as honey, does not flow readily and it is said to have large viscosity. The flow which is having very large viscosity, it is known as viscous flow. However, the fluid with zero viscosity, that is known as non-viscous flow. So there are some fundamental equations of fluid dynamics, like law of conservation of matter. It stipulates that matter can be neither created nor destroyed, as we all know, though it may be transformed by some chemical, mechanical, or electrical process. Since the study of this mechanics of fluids exclude chemical activity from consideration, the law reduces the principle of conservation of only mass. Now, next is law of conservation of energy. It states that energy may be neither created nor destroyed. Energy can be transformed from one form to another. Sometimes engineers, researchers sometimes loosely refer to energy loss due to friction, but in fact that loss basically transforms some energy into the heat. So nothing is really lost. Whatever you are using at inlet side, you are getting it the output. Next, law of conservation of momentum. It states that a body in motion cannot gain or lose momentum unless some external force is applied. So basically, it is the follows the Newton's second law of motion. Force is directly proportional to the rate of change of momentum. So next we are coming to the continuity equation, which we are using in fluid mechanics. Matter cannot be created or destroyed. It is simply changed into a different form of matter. So this principle is basically known as conservation of mass, and we use it in the analysis of flowing fluids. So continuity equation is basically based upon the principle of conservation of mass. For a fluid flowing through the pipe at all cross section, the quantity of fluid flowing per second is constant. Or in other words, for a steady and incompressible flow, rate of flow of liquid remains constant and different cross sections. So this is basically a you can understand the continuity equation. This is a pipe. Here area is A1, velocity is V1, and density of fluid is rho1. And at point number 2, area is A2 and velocity V2. So the multiplication basically A1 B1 will be equal to the A2 B2 at all the point of this pipe. Since we are using the same fluid for throughout the pipe, so density will remain constant. So A1 V1 equal to A2 V2. So this principle is mostly used in fluid dynamics. If the velocity, this is the derivation of this. Now I am skipping this part. Now application of continuity equation. So we can apply the principle of continuity